Welcome to the session. Greeting of the day. In today's class, we are going to see about a few PLC programming, PLC ladder programming. In such a way, it will be more helpful for the design of the mechatronic systems and it will be helpful for the future trends. So, from basic level, PLC programming, we have to see how far it will be helpful for our trends. So, that we are going to see some other examples. A device, a system using a PLC, yes, to control the CNC machine. Now we came to our mechanical CNC machine, how we are going to control. The machine starts to function, when a spring return, see we are using a spring return here. Spring return push button has been clicked. Spring return push button has been clicked. So we can use some other colors of green. Spring button has been pushed here. Therefore, is pressed. Now the machine is started. There are 2 to 3 points are there. The jaw of chuck in the lathe head moves. Jaw has the chuck has been lathe head have to move if detects the presence of workpiece using the sensor. I am keeping the sensor for the CNC operations, or keeping the workpiece for the CNC operation, and it has to hold it and should drilling, turning operations. We have to do that. Some lathe work operations to be done, some secondary treatments to be performed. So the jaw of the chuck in the lathe head moves if it detects it detects the presence of workpiece using the sensor to hold the workpiece. So jaw is going to hold the workpiece if the workpiece is detected there, and it holds, and it is holded down. The tool motor moves the tool bit close to workpiece after the workpiece has been mounted. So workpiece has been detected, and then the jaw has been holded. If the jaw has been mounted, then tool has to come nearby and the operation to be taken over. The tool motor moves. Motor is one output. Tool motor moves the tool bit close to the workpiece after the workpiece has been mounted on the jaw. These are interrelated. Now, after mounting, after the tool bit has been moved, this tool bit detection has to be founded, tool bit movement to be detected, and the coolant should supply simultaneously for the operations. The coolant pump pumps the coolant when the tool bit is detected near the workpiece. See, we have kept the workpiece holded. It means workpiece has been sensed and holded. This holding has been sensed and the tool bit came near, and tool bit movement has been detected and the coolant also comes near. For this we have to, and the operation has to be takes place. So what I am doing, S1 sensor to detect the workpiece. First it is detected, workpiece is there, and then movement of the jaw, and the jaw should come and it should hold. So that is I am taking as a one output. When it is detected, it comes near and holds. And the sensor to detect the mounting of the workpiece. So sensor, when it is holded, it is there, jaw is here, it is to be holded. When it is holded, it contains a sensor and it is detected, it is holded. Now that is I am considered as a S2. S1 it is detected and holded. S2 it is after holding we are identified. Then motor of the tool bit should come nearby. That is I am taking as a O2. O2 and motor of the tool bit should come near and it should do the operation. Now when the tool bit is moving, I am stationary. Tool bit is there. When it is tool bit is from the stationary position, it moves near to the workpiece. This movement has to be detected. That I am using the S3 sensor to detect the tool bit movement. Now along with that, if this S3 sensor is detected, what I am doing, output of that motor, pump motor I am on. Coolant is on, and then coolant should come, and coolant will be on and it should pump the coolant. So that is how 3 outputs are there, 3 sensors are there. How I can program here? Now first I am started. Push return, spring return. Spring return means we should give the latching process. So I have started here, it's been pushed, and then for the supply comes there and it is keep on connected. After pushing, what happens? This connection has been, output has been given to the input, and therefore this input is going to give the connection here. This is going to give the connection here. What happens? This push button is going to disconnect because it is a push button. It is disconnected now. The power is not there. Power is not came. But the power is giving to the internal relay through the latching process. So here it is the latching. Here it is a latching process. Right. Now what I am doing, when the motor is on, it is detected when the motor is on. And now the power is ready. Power is ready there. Now when the workpiece is kept, it is detected workpieces came down into presence. And then what I have to do? I have to hold. The jaw should move. And jaw is moved here now. Output. Output 1, movement of the jaw. It is moved and going to hold. Now after holding sensor 2. Now again the IR motor is running. Here also motor is running. At all conditions motor should on. Therefore it is ready. Motor is ready here. Motor is ready here. Now at second condition, jaw have holded the workpiece. Jaw have holded the workpiece. It has been detected. After holding, tool should come now. This connection gives the supply to the tool. So this is nothing but a jaw. This is nothing but a tool bit. This is nothing but a coolant. Now the tool bit has been operated and it is coming near to the workpiece to do the secondary operation. Now sensor 3 detects the movement of the tool and it has been saying it is moved. Sensor is sensed. And then the circuit has been again it is connected and gives the circuit to the coolant. And coolant is on. Therefore machine is already running. Jaw is detected. Tool is started. Then tool is detected. And then he is going for the coolant, giving the supply for the coolant and coolant is started. So operation can be done. So such examples we can able to do through the PLC program on the CNC. Now I am going for some other process. A device system using a PLC which can be used to control the movement of the piston in a cylinder using a 4x2 solenoid operated spring return. Here also we are using the spring return valve for the sequence of A plus and A minus. So here we want to understand a simple basic. Here I have a piston cylinder and I have a piston here and I have a piston. I have a piston here, right? So I am understanding this position as A1, otherwise it is as per name. I am mentioning this as A plus, and the last position, this point, I am mentioning as A minus. When the piston is moved, it is A1 to A minus, it should move. When it is started, when it is given the force, here the force of starting. So we will do now. The piston is to move. The piston has to move in one direction when the proximity switch at one end of the stroke is closed contact. When it is started, closed contact occurs, it should move in one direction. And in the other direction, and the proximity switch at the other end of the stroke indicates in the arrival there. Now what I am doing, the sequence starts only when the push button is pressed. The sequence starts only when the start push button is pressed. We have to start this action, push button. Also the device system for a cyclic process. See what I am doing first. See, I have given a start has been pushed now. A start has been pushed now, and then it detects the zeroth position, we will erase this, right? I have to do this. I have to A minus and A plus. I have started the cylinder, the action has been done, and then when the initial position of the piston I am understanding as a minus. Proximity sensor A minus, proximity sensor at one end. Next, A plus proximity sensor at the other end. A is the solenoid which are going to give the electrical power supply, or it is has to be starting to move. Now, I have a cylinder and I have a condition of piston to move from here to here, and I have a solenoid at this connection. Solenoid A should activate, and in such a way it can move. Now, this initial position, I am telling this initial position as A minus. A minus. And the position moved to the next condition here. I am naming this as A plus. What happens? I have started the push action now. Present. And now that at initial position, A minus is in contact. Therefore, as the A minus is in contact, I have not at all touched there. This position not at all touched. When there it comes, it should break the solenoid. Then we should off our program. We should start from here and we should reach to the A plus. Therefore, that is a break contact. This is a create contact. Now I have created. A minus has been initial position. When it is starting, we are creating, and the supply from here it goes there. Here I already connection by the nil condition, without a disturbance, it can able to pass the supply. Now the A is activated, and therefore this A is activated. This is A. So this is going to be the A. Solenoid is activated and piston is moving. When it should stop? Piston is moved there and it is going to reach this position now. Piston is moved there and is reaching this position now. The second position from here to here, it is moved. This is a moved position. After moving, it is going to reach the A plus. Now the A plus is detected from the nil position. It has been sensed. The input has been given. What happens? This input is going to break the contact here. This is the breaking contact. If the breaking contact occurs, what happens? There is no supply here. Therefore, it will disconnect those points. If it is disconnecting those points, the power supply is not going to solenoid. If the power supply is not going to solenoid, it is going to stop there. That is the process. Now I want to repeat this. The system cycling process I am doing. How I am doing there, you see? Start. And I have given us IR internal relay coil there. Start button has been pushed now. Start button has been pushed now. It comes. Stop button. It should cyclic process should take place. Therefore, purposefully, if I want to terminate, I am pushing the stop. Until then, it should work. Therefore, it is keep on going. And here it activates the internal relay. It want to keep on working until the stop button is pushed. Therefore, I am giving the latching also. I am giving this latching. It is going to keep on work. That's it. Now what happens? This internal relay coil is ready. And then at the zeroth position, A minus, at the bottom, A minus, and it is started to activate, it is keep on going. And then when it comes to the top one, A plus, and it A plus, and it is detected and it is went there. This process is going to become a cyclic process until the stop button is clicked here. When the stop button is clicked here, what happens? When the stop button is clicked here, it is going to disconnect. Therefore, the internal relay will not work. If the internal relay will not work, here also the connection won't work. Automatically the solenoid is going to stop there. So that is how we can able to create. This is a spring return solenoid. See, I have told you it is a spring return. When it is a cyclic process, when it is a cyclic processor, when it is reaches to the A plus, automatically it comes down. Automatically, it is due to spring action, it is slowly it comes down, and then it is slowly going to up and down, it is going to operate. So that is how we can able to do one of the example. Right. Some other things we will see about it. Up to now we have seen about only contact, brake contact, and relay coils and sequencers. Now further we will add something about the timers. Timers you can add. You see, a device, a timing circuit that will switch on an input after a delay of 10 seconds. A simple. When I am switching on, it should on after 10 seconds only. When I am switching on the bulb should not blink immediately. It should take a while of 10 seconds and it should on like a remote. I have given an input and circuit is going to the timer as a special function we have seen in the earlier slides. So we have seen here this is a special functions. We have a brake contact, we have a contact, coil, and the special function of timer and counter. We have seen all this. And we are discussing about the timer and counters now. So this we have to see the timer which makes the on position after a specified time. On the timer I have given a 10 seconds of time. Therefore after 10 seconds this output is going to give an input here has been given, and therefore from the power rail, and the power is started to move to the output, maybe the bulb as mentioned here, the output comes. Likewise we can use the timer. Devise a timing circuit that will switch on an output for 10 seconds and later it should switch it off also. We are not off, it's going to run. Here it is going to run. But here it is wanted to off now. We have to add a brake contact. Where we are adding, it's a point. So input the power rail and input is ready here. When we are connected, it should go. I have given an input. Therefore, this I am mentioning as a off timer. This I am mentioning as a on timer. This is I am mentioning as a on timer. This I am mentioning as a off timer. So, when input has been given, the circuit goes here and it is switched on the output. It means the bulb is blinking. In the middle you could able to see I have made a brake contact there in the name of timer. What it means? When that one is detected or sensed, it is going to break the contact. So that is what the point there. When it will be detected, I have kept the output here switched on. By the program, it should be off after 10 seconds. So when the output is given, this output has been taken here as an input, and therefore it gives the connection to the timer. It gives the connection to the timer for 10 seconds. After 10 seconds, this has to give the output. This output where it is giving, this I have connected at the top run in terms of brake contact. So when it is sensed, when the timer is getting the input, at nil position it is no input is there, it is going to supply. It is not braked. It is going to supply. When the supply is received, when the input is received, when it is sensed, it is going to break the contact. That is I named as a brake contact. What happened? So this connection, now I want to cut. So because it is going to terminate, so it is going to terminate now. So here only this is available, and it is nowhere. It is nowhere. The contacts are not available. So what happens? It has been terminated. Therefore, the connection is not going there. Connection is stopped there. So the output is terminated. After 10 seconds, this break the contact. What is the nil position? You see? What is the nil position? It is like this. Line is there. The break contact, it is at 0th condition, line is there. After 10 seconds, this line has to break. It is going to break in such a way the connections are not done. The circuit will not go. Therefore, it is called as break contact. So likewise, we can able to do some programs. The summary. In today's class regarding the PLC systems, we have seen about the contacts, about the ladder program, about the contacts, and about the brake contact, and about the relay coil, and about the timer, about the counters. So these things we have some with respect to advanced mechatronics approaches we have seen. The remaining part of the subjects we'll see you in the next session. Thank you.